Good morning, sir.
Yes, good morning.
Good morning, sir.
How are you doing, students?
We're doing good, sir. How about you?
So, how are you?
Yes, I'm also doing fine. Very nice to get you back in the class. Yeah. So can you remember when was the last class? The date of the last class? Do you remember?
One minute, sir.
Yeah, no problem.
Sir, I guess it was on the 28th.
Yeah, I can also see that. I was just confirming if it's correct.
Sir, can you upload the last class's video recording?
Oh, so you need the video recording. I didn't do that, right? Okay. I'll do that along with today's class. Yeah,
Okay, sir. Thank you.
great. Thank you for reminding me. So let us have a look at the syllabus because we had a gap. So better to have a look on where we are actually. Can you see the file? The syllabus file? Can you see the syllabus file?
Yes, sir.
So actually in the syllabus file, if we look at where we are actually, we have already done all these things: formula, function, data table, financial statement analysis. We have also done the case study. Then we have also discussed the time value of money, right? So we have discussed the future value, present value, single and multiple cash flow. We have also done spreadsheet functions for finding the future value, present value, rate, periodic cash flow. Now, and also we have done the spreadsheet model of a loan amortization schedule. Do you remember? So I'm going to show that, review that as well. Loan amortization schedule.
Yes, sir.
Yeah, we have done that. So what's next? Actually, next is, you are supposed to, that is an assessment. That is assessment. That means you have to solve the case, and I'm going to ask you to randomly ask you random questions to show it on during the class. So the case solution on time value of money in Excel. So that is going to happen. That is going to happen in the next class actually. So by this Friday, you will already get the case, and this time the case is not going to be very big, so that you can submit before the next class, and also present during the next class. Okay, and you know that in the second case study you have 20 marks allocated, like the first one. So today, what we are going to do, actually today we are not going to have 3-hour class, rather a bit shorter duration. So today I'm going to review the time value of money another time so that you can catch it up. And also I'm going to demonstrate a very short case so that you also have a kind of exposure, another exposure to case solution related to time value of money. Now, this is the file where we have actually done all the spreadsheet analysis of future value, present value of single cash flow versus multiple cash flow, different types of multiple cash flow like annuity, then perpetuity, and all this thing. Okay. Varshita and Dipshika, you can have the lead, no problem. Okay. So, do you remember about this worksheet? Can you hear me?
Yes, sir.
Okay. So the first one is present value of a single cash flow given the discount rate and a cash flow, one cash flow in year 4. So how do you calculate the present value? This is simply the this is simply using the function called PV. Sometimes we do not know how to whether a function is appropriate or not, or sometimes we do not know what should be there in the function, like whether it should be the discount rate or it should be the single amount of cash flow. So in that case, actually you can always take help of the internet. You can search in the internet by typing the keyword like present value in Excel function, something like that. Okay, so this is a well accepted practice. It is not possible for human being to remember, to memorize all the functions. So it is always acceptable that you can actually search for the function, read the function's structure and all this thing and apply that. That is not a problem at all. Okay. So we have done the present value of single cash flow. We have also done the future value of single cash flow using the FV function. Then we have done the present value and future value, of multiple cash flows, having different cash flows in different years, We have done that. We have calculated the present value. How did you do that? We have calculated the present value interest factor. So there is a little theory behind that, which has been discussed in a previous class. And then if you multiply the present value interest factor with the cash flow, you get the present value of that individual cash flow. And if you do that accordingly, if you add all those, then you get the present value of the total set of the cash flows. Similarly, you do for future value. Later on, we have moved to the case where the multiple cash flows are actually equal. All are $120. All cash flows are the same. So every year you are getting or giving whatever, the same amount of cash flow, $120, $120. So these kind of cash flows are called annuity. When you have equal cash flow every year, we can call it annuity. You can call it annuity, right? Okay, so there are two types of annuities. We'll talk about that later. But normally, by annuity, we mean the ordinary annuity. That means the cash flows will occur at the end of the year. So you can calculate the present value using the same manner of calculating the present value of unequal cash flows in different years. You can use the same structure, same process, no problem with that. But you can also calculate it using the PV function that allows you to use a very small function to calculate the present value of annuity. like here PV, then you give the rate, then number of period, and number of period in this case is 10, then the equal amount every period, which is called PMT. And so if you use that, then you will get it very easily, instead of doing all this whole lot of calculations. You can use the single function to do that. Again, if you want to calculate the future value of the ordinary annuity in a particular year, at the end of the last year of the equal cash flow, you can also do that using the FV function. As you can see here, you need the rate, which is 12%, the number of period, which is 10, then PMT is the equal cash flow every year, and then PV is 0. And 0 indicates end of period for ordinary annuity. Okay, so this is how you have done the present value of multiple equal cash flow, which is called ordinary annuity. Now, the same thing will be done for the annuity due, in which case your cash flows are occurring at the beginning of period. So if you contrast these two, in this case, year one cash flow is happening at the end of year one, but in this case, year one cash flow is happening now. That means beginning of the year one. And year 10 cash flow is happening at the beginning of year 10, which is also the end of year 9. So the whole cash flow is moved upward by 1 year. So in this case, you can also use the PV function, but remember at the last, this 1, instead of 0, you have to put 1, which indicates that the cash flows are occurring at the beginning of the period. Okay. So for future value, same thing, only the function is different. Instead of PV, you have FV. Any question up to this? Any question up to this? No. Okay. Can you hear me or not?
Yes, sir.
Yes, sir.
Okay, now perpetuity, we have already discussed that. Perpetuity is the case where the annuity never stops. The annuity is continuing forever. It will never stop. So the formula is very simple. Just equal cash flow divided by the discount rate. We have already discussed. And the growing perpetuity is the case where the cash flow increases at a constant rate. And the cash flow increases. Let's say the cash flow is 100 and it will increase at 2%. So the following year it will become 102. In the next year 102 times 1 plus 2%, and so on, and it will continue forever. So in that case, the formula is the the next year cash flow divided by the discount rate minus that growth rate. And this is how we have calculated the present value of the growing perpetuity. Okay, after that we have discussed about a case of loan amortization schedule. The case of loan amortization. So what is that actually? That is actually the case of taking a loan. Do you remember we have given an example of building a classroom in an empty space of your campus? I have shown you a photo of a field, open field, where we have some place. So we have said that for building that classroom building, we have some amount of money, but we also need another loan of 25 lakhs. So if we want to take the loan of 25 lakhs, and the bank is charging 12% interest rate, and we are going to repay the loan in equal installment, equal yearly installment in 20 years period, right? So the first challenge is to estimate the amount of installment. Okay, so if we carefully look at it, we find that it is an annuity because our installment is equal every year, and it is limited for 20 years. So it is similar to this one, You can see we have 120, 120, 120 every year, and this is limited for It is limited for certain number of years, 10 years in this case, but in our loan case, it is for 20 years. So it is also an annuity. Do you understand? So to calculate the annuity, just 1 second here. Okay, sorry about the interruption. Actually, I was having right now I'm in the office. Our campus has started offline. Have your campus started offline classes?
Yes, sir. Yes.
Right. So I was having a problem
Sir,
with.
can you tell how yearly equal installment is calculated?
Okay, so I was having problem with my office computer, so the technician came and I was giving a little instruction about that, so that he can fix it. Anyway, so I was talking about what? I was talking about the. I was talking about the. Can you help me to remember? I was talking about the installment and why it is an annuity, right? So, so have you understood that it is an annuity?
Can you tell how yearly equal installment is calculated?
Yeah, I will tell you how the yearly installment is calculated. But before that, you have to understand that it is an annuity. Have you understood that it is an annuity?
Yes, sir.
So there are two conditions, three conditions to become to consider a cash flow set of cash flow annuity. Number one, cash flows must be equal. So in this case, the condition is the loan will be paid in equal installment. So the first condition meets. Second condition is what? What is the second condition? The equal cash flow must stop somewhere. So we can see that it is a 20-year maturity. So after 20 years, the equal payment will stop, right? So this is why we can consider it as an annuity, right? Oh, another condition is the cash flow must happen in equal interval of time. So because it is yearly, so we can easily understand that it is happening every year. So the duration between two cash flow is always 1 year. Okay, great. So now the question is how, so once it is an annuity, we can always use the PMT function. Use the PMT function. So PMT function is applicable for calculating the annuity. So let me tell you how to find the PMT function actually within the Excel. Within Excel, if you want to find the appropriate function, you can click this FX or something like that, and you can search for a function here. Normally, when we search with the keyword, we get the function. If not, we have to look the financial functions one by one. Anyway, let me try. Let me write annuity, then installment, something like that. We don't get anything. So the idea is to change the keyword. Perhaps we can write only installment. Not working. Perhaps we can also write, and I have already experienced this before, as you can remember. It can be a problem with the version of the Excel, or because I'm using Mac, that can also be a problem. Anyway, let me try. Another one can be payment. Nothing is working. Okay, so if this is the case, the option is you can always go to the internet and search Google, but I'm not going to show that because you all know better than me how to search Google. So what you can do, you can search for, you can look for the financial functions. Within the financial, you can look at the names and you can gauge whether, let's say somehow you think that the sorry, where did it go? Okay, somehow you think that NPV could be the function, or NPR could be the function. Now you see, read the description. What does it return? If you use the NPR function, so what is the outcome? It says that returns the number of periods for an investment. So returns the number of period. In this case, we are not looking for number of period. We are looking for the equal amount of payment, right? So that is not going to be the right function. So you can read as many as you want. So if you go to the right one, you can match it with what you require. So PMT, if you use the PMT function, then it calculates the payment for a loan. So this is what exactly we are looking. Based on constant payment. So equal installment means constant payment. Okay, and a constant interest rate. And we also have 12% constant interest rate. Okay, so this is how you can actually look at the functions, and also you can read the description, the syntax, the structure of the function. You can see it has within the function, we have rate, NPR, PV, FV, type. So you can also read the explanation. What does NPR mean? NPR is the total number of payment. So in our case, because it is a 20-year loan and we have equal annual installment, yearly installment, so there must be 20 payments. So NPR is the number of payment. Okay, rate is the percentage rate. Okay, and we also have something extra here. You can see rate is the interest rate per period for the loan. Okay, so if the period is a year, then we have no problem because already 12% is the yearly rate of interest. But sometimes the loan can also be repaid in quarterly installment or monthly installment, in that case, you need some kind of adjustment. Let us see what. So in this case, they are giving an example that for quarterly payment, you have to divide the yearly interest rate by 4. That is well justified, because if the yearly interest rate is 6%, then definitely the quarterly interest, that which is 1/4 of a year, quarterly interest will definitely be 6% divided by 4. Do you get it? So this kind of adjustment you might need to make. So when you use the software, do not let software do everything. You have to direct the software what to do. Okay. So all these are already known to you, so I'm not going to do it. So here I'm doing it again, equals PMT, to avoid the minus negative. I'm giving my negative at the beginning. PMT within bracket. Now you see the syntax here. Red is this one, then comma, number of period, payment or period is 20, comma, the PV, present value of the loan, is 25 lakhs. We don't want any ending balance. We don't want any ending balance. That means after making 20 installment complete, we want the loan to be fully repaid. So the future value is 0. Okay. Now close. And you get the same value. So this is how we have to calculate the yearly equal installment. I'm deleting it because we have done that already here. And after that, we have done the loan amortization schedule, which is essentially the detailed breakdown of what you pay, and out of that payment, how much is interest payment and how much is principal repayment and what is the ending balance every period. So this detailed breakdown is called loan amortization schedule. What we are going to do now, we are going to do this one again, but for another case where the loan will not be repaid every year, rather it will be repaid every month. So do you want to do that? Do you want to see that, how to do that?
Yes, sir.
Okay. So let me write the case here, very small case. Suppose, I'm just building the example right now. Suppose you are going to a loan of $10,000 from a bank that charges 8% interest. The loan has to be repaid in equal monthly installments. In how many years do you want to repay it? Let's say 5 years. Okay. Prepare the loan amortization schedule. Okay. Now let us write down the summary information here. Loan amount. Are you following me?
Yes, sir.
Okay. So look at follow me very carefully, and after doing it, I will give you maybe 5 minutes time to do it in your computer. and then I will request some of you to demonstrate in the class. Okay. So loan amount is 10,000. Then interest rate was 8%. What happened? Interest rate is 8%. Then maturity. Five years. Okay. Now, at first, what you need to do, you need to calculate, although you are to prepare the loan amortization schedule, but without the installment, can you prepare the loan amortization schedule? Think and answer me. Without calculating the installment amount, can you develop or structure the loan amortization schedule?
No, sir.
You cannot. Look at it. Look here. This loan amortization schedule needs the installment. So you need to calculate the installment. Okay. So let us write down monthly installment. So the reason I'm showing it is you actually need a lot of adjustment in your function, in the function to calculate when you have something, the frequency of installment is not yearly. So monthly installment will be equal to minus is for avoiding the minus sign, PMT, that is for sure. Now you can see the syntax. The rate, what will be the rate? The rate is this one, but remember this 8% is yearly rate. You know, if nothing is mentioned, always the rates are expressed in year, on yearly basis. But your installment is monthly, so you cannot really use the yearly rate. You have to convert it into monthly rate. So how many months do you have in a year?
12, sir.
12 months in a year, right? Okay, so divided by 12. Now it becomes a monthly rate. So now the standard period, so far we have used year as a standard period. Now we are getting month as a standard period, right? So the rate is this one. Then number of payment. How many payments? Is it 5? How many payments? Is it 5 or what?
70, sir.
So how do you get that? Number of year
Into 12.
times 12. Okay, times 12. Okay. The preferred way, let me delete this one and do it again. A better way is like this. Insert. Now let me write number of compounding. So how many times we are actually doing all this thing? That is 12. Let me move everything one cell. Okay, so by number of compounding in a year, we mean that we have to calculate the interest and make payment 12 times in a year. This is why we are saying 12 is the. So actually, I do not want you to write down the number in the function and formula. You just refer to the cell. So that if we change this one to 4, the function will automatically change. That is the reason. Okay, so let me do it again. So monthly installment will be equal to PMT or let us avoid monthly, just write installment. Amount of equal. equals. So now the rate, I have already explained why we have to divide by this one. Okay. So rate divided by number of installment in a year, comma, 5 times 12, comma, the present value of our loan is 10,000. That is a present value right now, so we don't have to adjust that one. And future value we want 0 at the end. Okay. So if we do, then we get 202.76. Do you understand everyone up to this? Any question?
Yes, sir.
No question. Okay. So now let us do the loan amortization schedule. You know that in the loan amortization schedule, the first one will be month, because in this case we have month, but let us write period, because in case we change from month to quarter. Okay. So period, how many periods do you have? We have every year we have 12. So in 5 years, we have total 60 periods, right? Right or wrong? In 5 years, how many months do you have?
60, sir.
60 months. Now the beginning balance. So the first beginning balance will be equal to the loan amount, right? Then installment. Monthly installment we have already calculated this one, and we are going to lock it because we will copy it down and we don't want it to change. Okay, now I'm going quickly because I have already shown all the calculation and explanation before. So after installment, we have out of the installment, how much is the interest payment? Interest. So interest payment will be equal to the beginning balance times, look very carefully, beginning balance times the interest rate. But remember that it is not merely the interest, because the period is 1 month, right? Because the period is 1 month, so we cannot apply yearly interest rate. We have to apply monthly interest rate. So it will be divided by 12. Yearly interest rate divided by 12, and the whole thing should be locked. Because every time when we copy it down, the rate will be the same. Only the beginning balance will change. This is why we are not locking that. Okay, and this is the interest payment. And let me reduce the decimal point. It doesn't look good. So many decimal. Okay, now principal. Repayment. So principal repayment is the installment minus interest payment. Now ending balance of the loan after 1 month is equals to beginning balance minus the principal repayment. And in the second month, it will be the first month's ending balance will be the beginning balance of the second month. Now we can copy these calculations down for 1 month, and then we can copy the whole thing down to 60 months. And if you get 0 here, then you will think that the calculation is okay, because after 60 months, there should not be any loan balance remaining. Okay, So you can see how short time, how short is the time you need to calculate the whole thing for 60 months, and how much time you could have needed if you do it on pen and paper, on a paper, right? So this is the loan amortization schedule. Bold. Now another thing, I want to show you another thing. Let's say instead of every month, you pay the installment every 3 months. So if you do that every 3 months, then what will be the number of compounding in a year?
Sir, can you repeat the question?
If you pay quarterly, that means every 3 months. So how many 3 months are there in a year? There are 4 quarters. So it is going to be 4. So in that case, if I change it, everything will automatically change. And remember, in that case, our number of period will be 20. So let us check. Yeah, you can see in 20 period, we have got 0 balance. So the remaining are irrelevant. Okay, those are irrelevant. We can ignore that. We can ignore that. Similarly, let us convert it back to 12. Let's say we pay the installment every day. We pay the installment every day. So how many what is the number of compounding in a year in case of daily installment payment? How many days in a year?
365, sir.
365. Nice. So you can see the installment is only $6.65, and 60 period is not enough. Now, how many periods? We can just have a very short calculation. 365 times 5 years. So 1825. So let us delete it and copy it down to 1825. So let's see where we get 0. Yes, 1020, 1000. So we don't need any more. Just delete the remaining unnecessary part. Okay, so in that case, you can see that our loan will be repaid after 1825 days of installment, loan amortization schedule. Okay, have you understood?
Yes, sir.
Yes, sir.
Great. So I'm giving you about 5 minutes time to practice, practice maybe a little part. Okay, then practice a little, and then I will request to voluntarily come forward or randomly ask anyone to show only the monthly part. I have just shown you the compounding in a daily compounding and quarterly compounding, but you can do that at home. But for now, this one is sufficient. 12. Okay. So you get 5 minutes time to practice. Okay, I'll come back after 5 minutes and ask you. Okay, are you done with the practice?
Yes, sir.
Okay, giving 3 more minutes. Okay, please continue. Who wants to come forward? Anybody voluntarily?
So can I?
Anybody? Yeah, please, Pradeep, come forward.
Sir, can you enable the screenshot option?
Yeah, okay. Yes, I have enabled.
Sir, can you see the screen?
Yeah, I can see.
Yes. Sir, as per the question, it is given that loan amount is 10,000 and interest rate for the it is of yearly. So in the question, it is mentioned that we should be payment monthly. So you need to convert it into monthly. So dividing the interest rate
So
of
is it okay, Pradeep, if you delete the calculations and do it again? Also the loan amortization schedule, the calculation part, you can delete and do it again. Then it will be helpful for all of us.
sir, is it okay now? Can I start now?
Yes, please continue.
In the question, it is mentioned that it is of 10,000, the loan amount, and the interest rate is of yearly is 8%. As it is in question, it shows that we need the interest rate in the monthly, like we are payment in, we are making a payment monthly. So we need to convert into monthly interest rate. So dividing the interest rate of 8% with 12 months, it gives the monthly interest rate. Then after the maturity of the loan is 5 years, and we are paying a loan payments in a monthly, as we are is a equal monthly installment. So we need to convert the monthly maturity of the loan into months. So converting of 5 years into months is nothing but multiplying 5 years with 12 will give the total number of months in the maturity of the loan, like in 5 years. Coming on to monthly equal installment is PMT, like equal to minus of PMT, as the it is in the rate, we know the rate is 0.67% for monthly. Then after, the number of periods is like maturity of the loan is 60 years, 60 months of 60. Then after, the present value is loan amount is the present value of 10,000, and we don't know the future value of Z, it will be 0. And it is a end of the beginning, so it will be 0. And we got that monthly equal installment. And the loan in amortization schedule is like is maturity of the loan is 6 months. We will take that months of 60, and the beginning balance will be like loan amount of 10,000. The installment is monthly equal installment of is like monthly installment will be same for all the period of 6 months. So we can fix it with the dollar signs. And the interest payment is of interest payment will be is dependent on the beginning balance of the present or the current month. So in this is the first month, it is of 10,000 multiplied with the interest rate of monthly, and it gives the 66. And here the interest payment will be fixed for every month. So we can fix the interest payment for every month, like $20 cents. Then of the principal payment is nothing but install payment minus interest payment. Use the principal payment, and the remaining balance is 10,000 minus principal payment. Of Excel functions, we can find this. We can find it for 60 months.
Actually,
Beginning balance for the second month will be the remaining balance
before
of
popping down, you have to do it for the second month as well, because the second month
Sorry,
beginning
sir.
balance is not 10,000. Okay.
Yes.
Now you can copy from month 2. You can copy. Yeah.
It's done, sir.
Yeah. Right. Good. Very good. Anyone else want to show? Okay. Okay, so do I have the class representatives in the class? Can you respond?
Yes, sir.
So Omar,
Yes, sir.
Omar, you are the class representative, and we also have another class representative, right?
Yeah, we have Varshita and Govind.
Is she here?
Varshita, I'll see, sir. Not there, sir.
Okay, no problem. So Omar and another class representative, particularly because you are here. So have you sent all the attendance to me so far?
Sir, our class just got new CRs. So previous Vinila was taking attendance for your subject.
Mhm. So now who is taking?
Now Govind is taking.
Okay. So Vanilla, is Vanilla here? Probably Omar, you can take the responsibility. Contact Vanilla and also Govinda and make sure that I receive all the attendance report up to today. Okay, is it possible for you?
Yeah, sir. I'll talk with Vinila.
Okay, please do that. Probably she has already sent me, but just to confirm.
Yes, sir.
And if it is easily possible, then send me again. Okay, that is one thing. And the other thing is actually our class time has to be changed because in my university, new trimester has started on campus. So there is a conflicting time. So probably from the next week, our class might be on another day instead of Wednesday. So I have already informed your university and they are trying to solve this one. So you will get that information about that. Okay. Another thing is your next case study. You will get the instruction like before. And I will send the next case study document to you by this Saturday or Sunday, by this weekend actually. Then you will also solve that one and send me. And the other thing is I will also give you the lecture videos so far. I think I have to give 3 lecture videos, right? So I will upload that. If you do not get that by Sunday, please remind me, someone of you, particularly the class representative. So today I have to end the class now. If you have any question, you can raise. Otherwise, the class will be over for today.
Excuse me, sir.
Yes.
The students were asking for Excel notes also. like the
This
file.
this file. Okay, okay, okay. I will give that one also.
Yes, sir. Thank you.
So thank you very much. I will see you again in the next week.
Thank you, sir.
Thank you, sir.
Thank you, sir.
You're welcome.